Okay folks, so today we are looking at inverse functions and composite functions, which is all part of the functions and graphs chapter at the beginning of, which is chapter 2. So we're still sort of early days of year 2 pure. I'm going to crack into this Terry's chocolate orange that I've got left over from Christmas, whilst you write that down and see what you can remember of what to do with that, and I'll go through it in a moment. An inverse is a reverse procedure. So to work out what it is as an inverse, the simplest way I know to do it is to let y equal whatever your function of x is, and then rearrange to make x the subject of the equation. So you're finding out what you would do to go the other way. Now, this is quite obvious, this one, because you're timesing by 4 and then taking 1, so you just reverse that process. So the last thing I said was taking away 1, so we add 1 to both sides, gives us y plus 1 equals 4x, and then we divide by 4 to give us y plus 1 over 4 is equal to x. And then all we do is now replace y with x, and we can say that the inverse function of x is going to be x plus 1 over 4. That doesn't make sense. Let me know after you've watched it a second time, and I'll go through another one or two for you. Right, composite functions are a little bit strange, because composite functions mean that you've got to do this one before that one. Sometimes it's written as a composite function of with x going in there, and if you look at the bracket then think, well, I'm going to multiply the bracket by this one first and then that one. That's how I sort of think of it. So what you need to do, if you do function f of x, you're going to get 4x minus 1. You then have to put whatever you get from 4x minus 1 in as your value of x. So what you really need to do for this is simply do the g one, because it's the second one, but substituting 4x minus 1 in for your x, which looks something like this. 4x minus 1, put it all in there as a bracket first of all, and then you just need to multiply out and simplify. So if I multiply that bracket, I get 8x take 2, but then I've got that other 1 to take away. So my final thing for the composite function would be 3 over 8x take 3. And the third part of this question, the values of x for which 2 times the f of x is going to be gx, well, all we have to do is double our function of x. So we've got 2x equals g of x, so I'm going to put 2 times my 4x take 1 is going to be 3 over tx take 1, and we then need to solve that equation. So pause the video and have a go at doing that if you hadn't done it already. First thing I'm going to do is expand that bracket to give me 8x take 2 equals 3 over 2x take 1, and then multiply both sides by 2x minus 1, which is going to give us 8x take 2 times 2x take 1 is equal to 3. We then need to expand this bracket, so take your time, use a grid to make sure you don't make a mistake. 2x times 8x is 16x squared, minus 1 times 8x is 8x, negative 2 times 2x is negative 4x, negative 2 times negative 1 is plus 2. So peanut those two, and we get 16x squared plus 4x plus 2 is equal to 3. Make the whole thing equal to 0. 16x squared, add 4x, take 1 is equal to 0. Now we can't divide by 4 because that's 1, isn't it? It's not a factor of 4. So what do we do now? Not a multiple of 4, I mean. So now, at this point, trying to factorise that, notice in the question it says give your answers to 3 decimal places. So it's either time to use the quadratic formula or your calculator. So if we take out the calculator and go to equations, polynomial, and I've already put it in earlier. Now when you hit the answer though, you've got to be really careful here because it says to leave our answers to 3 decimal places, but when I do that I get my 0.8256, so I know that my first value of x is going to be 0.826. My second value of x, it looks like there's my 3 decimal places there, but do be careful because I noticed this. I got curious, chucked that into my normal thing, and if I do that, and there it is, 3 minus root 13 over 8. It's not actually exactly. The reason I did that was I had misread this originally and was thinking I was going to leave it to 3 significant figures, which it wasn't quite yet. So for that reason, I do not know why the calculator rounded it incorrectly, but 3 decimal places would actually be 0.076. So that's just a word of warning to watch out, because you don't want to lose a mark for accuracy on that, do we? Right, so having done that, have a little crack at, oh hang on, what was I just thinking? I know there's something else. Oh yes, when we give the composite function, what would it ended up being? It ended up being that. Now what you should always do is you should be putting down the domain, the values of x that you can put into here in the first place. And because we divide up here, you notice that it's all real numbers, any that you can put in there. For 3 over 2x minus 1, as well as all the real numbers, it also says not a half. Now the reason for that is if you were to have a little look at the graph of 3 over 2x minus 1, see I've very kindly set this up for us already. You see here we've got an asymptote coming in here at a half where you've got no real values, and that's because if x is a half, 2 times a half is 1, 1 take 1 is 0, and you know we can't divide things by 0, can we? So we're going to get a similar thing here. So I should be setting up with me funny little bracket, if I can draw it, there we go, that x is all real numbers, but x is not. Now how am I going to work out exactly what, but it's whatever's going to make the bottom of the fraction equal to 0, isn't it? So 8, if I've got 8x take 3 equal to 0, 8x would equal to 3. If we add 3 to both sides, x would be 3/8. So for that reason, we've got to put x cannot be 3/8. And if you don't pop that in there, you're going to lose a mark. So that bit is important. Right, so having done that, this is the question I'd like you to have a go at. It's on the class charts as well, but it's from page 54. Actually, it's not on class charts, it's just here and it's in your book. So page 54 of the mixed exercise, question 2. We've just done question 14. We've just done question 13. All the questions in that exercise are going to be relevant, but we will be moving on to some others tomorrow that are sort of similar within that field. So just do that. If you can boss that, then that's great for today. Just make sure you've done everything else that you need to do leading up, or maybe do some others a bit like it. Cheerio. See you, well, some of you tomorrow, some of you later on today, isn't it?